twin of your product from design to manufacturing. And what I would like to start with is also to talk about there is not only one digital twin when you talk about electronics design. This is why they have to become really one part of the entire development process. We talk about integrity and integration. So how do you make sure that you have a digital thread of your data and you don't have to re-enter the data multiple times? Whether it's design, whether it's library, whether it's the integration between ECAD and MCAD. You heard Maya talking this morning potentially about how to establish that digital thread from the NX side. We talk about not only integration, but also secure integration. How do we help our customers to have a secure integration and secure collaboration between your engineering organization, within your engineering organization, between the different sites of your engineering and your partners and contractors, and do this all efficiently. And at the end of the presentation, I will close this up with the top 3 benefits that we believe that you will get with that integrated digital thread. So when we talk about the goals that our customers are communicating, quite often you hear the typical things like time to market, getting more efficient, getting more cost efficient. These are the typical things that our customers are often saying. But there are new challenges coming to the horizon that we see becoming more and more important. The first one is, of course, the talent shortage. How do you do more with less people, because all your great talent is about to retire? Some of them is going to be retiring. So how do you make sure that knowledge is going to be transferred, and you have to make sure that that knowledge can be reused? The second one that we see more and more coming is the fact that, of course, all the different trade challenges and supply chain challenges are going to become an issue. And when I talk about supply chain challenges, I'm talking not only what's going on with COVID, what happened with COVID. All of a sudden you had shortage of components. How do you make sure that you have alternative parts, and you make sure that you have that digital thread and traceability of how those components will become available for your product development? But that volatility is definitely a big challenge. And of course, in addition, with the recent situation coming out of US, you have that volatility in terms of tariffs, export control. How do you make sure that you have a digital thread that not only looks into Teamcenter, where you have the export and the BOM control, but you enable your engineers to make better decisions in the context of what's available in Teamcenter much earlier in the process, and accelerate your secure product development. So these are some of the big challenges that we are seeing. But in order to get these challenges addressed, you have to really look into what are how does the organization look like. So when you look at the middle, you have a lot of the different personas that are involved in product development. So starting with the system engineer, then you have people that are creating components, parts in your organization. And these engineers have to create the data in a consistent fashion with what's going on in Teamcenter. But then you have the electrical engineer, simulation engineer, the PCB design engineer, who are doing the actual electronics development. In addition to the MCAD engineer, who is using NX or some other mechanical tool, and they have to work very closely with electronics engineering, because it's not, when you look at electronics engineering, electronics design, it's not a electronics design, it's an electromechanical co-design. These engineers, these users have to work tightly together throughout the process in order to make sure that you don't have any issues and any gaps in the development process. And then of course you have the release manager. This is and people that are working on Teamcenter, who have to look at the components, at the BOMs. They have to make sure the product is producible and have to manage the life cycle. And ultimately the manufacturing people that have to consume the data. These are the different personas in a high level who are working on electronics design. When you look at how the data is threatened throughout the process. We talk about 5 digital threads. I will dive a little bit deeper into those digital threads in a second. What are the 5 different digital threads? You have the architecture. Somebody has to define from the top level how the product is being developed. And that information has to flow throughout the entire process. How to make sure that the architecture is going to be met? How do you make sure that changes that are going to be in the architecture are going to be updated? And the same applies for a component, because component life cycle is continuously changing. The design life cycle, you have the verification life cycle, which is starting with the digital thread on the architectural side to come together on the top level of the V. You have to make sure that the model that you define here on the top needs to be verified over there in the digital twin before you even start doing your real actual physical implementation. And then of course the manufacturing digital. So today, when you look at data that is going to be handled from design to manufacturing, it's typically very discrete files. If you're familiar with the electronics design, there's Gerber, there are drill files, so there are very discrete files. What we are looking at is making sure that we are going to provide the manufacturing organization with the manufacturing digital twin. It's really a one single object that is coming out of electronics engineering. We hand it over to the manufacturing team, and that manufacturing team can then take that digital twin and extract the data in a way that it aligns with the production line, with the bill of processes, and with whatever is needed in order to get the board built and the board assembled. Now, when you look at the digital twins, that is the interesting part, because when you look at electronics design, electronics system is not one digital twin, it's 3 digital twins. You have the logical, which is the schematic. You have the electrical, which are the constraints. You have the physical digital twin, which is your board with the mechanical enclosure. Now, when you think about these 3 digital twins in electronics design, they're not changing one at a time. They're all changing at the same time. While the engineer is working concurrently on the logic, somebody else is changing constraints. Somebody else is potentially doing the layout, maybe on the mechanical side doing the pre-placement. So all these things are changing at the same time. And the goal and the mission is to ensure data integrity at any point in time so the data is always the same. That is one of the key challenges. Then of course you have to leave alone that the requirements are continuously changing. And when the system engineer is changing the requirements, of course, that has impact to those implementation digital twins, and it will have impact to the manufacturing digital twin. So you see the complexity that we want to navigate, that we need to navigate as customers, as users, as we are going to integrate electronics, have to ensure data integrity throughout the entire process, up into a team center, over into manufacturing. So really quick, and you will get the handout of these slides. We'll talk about the digital threads that we described, and those 5 digital threads. I'm using that slide here a little bit as my table of content for the next few minutes, talking about the architectural digital thread, how we address that. Then we look at design and component, how we integrate that as a digital thread with Team Center. Then we quickly look into verification and manufacturing. When you talk about the threading, you quite often see the picture of Team Center being the single point of truth. The challenge is that is absolutely correct. Team Center is the single point of truth by the time your data gets released and your data goes into manufacturing, into the life cycle. Prior to that, you have the engineering domains on the bottom left that are continuously having to deal with those changes. The mechanical system has continuous changes, electrical system has continuous changes, software has continuous changes, and of course electronics. And this is why we are we have to introduce the domain data management, because the domain data management is then helping the engineer to make sure they have all the information at their fingertips to make very quick decisions and then ensure that the integration with Teamcenter is structured and ensures that there is a qualitative data set in Teamcenter. And since we don't need all data from the domain in Teamcenter, we call it a curated data set. It's important that whatever Teamcenter needs to delegate to transfer into the domains, it's not a full data set. And what the domains are transferring back into Teamcenter is not a full data set. So you have to look at what is relevant and who is the master of this data, and then ensure that the data is going to be integrated through workflows and through ideally out-of-the-box processes. So this is why we always talk about engineering data management or expedition EDM on the electronic side, besides all these other different work in process data management tools that are integrating with Teamcenter. So let's look at in the architecture digital thread. So the architecture quite often means model-based engineering for most customers, model-based engineering. Now, model-based engineering, the challenge with that is, of course, to make sure that the domain is able to absorb the data that is coming from model-based engineering. And we were looking at this and looking at the models, whether it's the definition or whether it's the verification. And see, okay, how can we address the challenges of our customers in a more effective way? And so we broke it down into an architecture that is representing a little bit our vision, but pretty much you have your information on the front, on the left side, and then the domains are going to get that information through a SysMLv2 API. And the reason is that the reason why we are looking at SysMLv2 is you need more than a informal interface, you need a proper API, and you need to be able to not only transfer budgets down into the domain, but if my engineer is going to get the requirement that the system shall not use more than 1500 watts, and I only need 950, I need to have to give that budget back to my system engineer in order to make sure that he's going to refine the system. So that bidirectional communication is critical, important, and something we are focusing on. In the first phase, we are going to take the requirements as a part of our domain-specific requirements through Recifile, through integration from the requirements management system, and transfer that into the domain. Then you build a test plan, and according to this test plan, you verify that you're going to meet that requirement. That's our phase one. And we can definitely dive deeper into that if you're interested. So that is a key area for our investments to make sure that we are going to deliver model-based engineering functionality to engineers that they can absorb and they can actively use today. The second part is, of course, then looking at design and the component digital thread. I believe that is the most important piece that you're looking at. How do I bring my data from electronics engineering into Teamcenter and back? And this is where we put a lot of effort into the different elements, whether it's the infrastructure, whether it's CAD/COM alignment, whether it's the alignment of 3D models and library synchronization, and I will talk about all these in a second here. And of course, then looking at integrations with the iframe or the supply chain in general. Security is an important piece, increasingly important piece. I know this is an eye chart, but it gives a great overview of what we believe is a proper digital thread between, on one side, what's available in the cloud, data that your engineers need, what is needed on the engineering desktop, how the tools work together in order to establish that digital thread in the engineering domain, and how that all works together with the PLM, the Teamcenter environment. So the concepts are really simple. So you have the engineer looking at the library. The library is something that is providing them with information that has been curated and has been maintained put under life cycle by your component engineering and librarian team. But there will always be components that your engineer needs that are not in the library. So they're looking up into environments like PartQuest as a wireframe in the cloud. Pull information, put them in the part request, make sure that the engineers, the component engineers, get the data digitally, so they don't need to re-enter the data. Look at form, fit, function alternatives, etc., and put them in the library, in this case, EDM. And the engineer is then using schematic and layout in order to do the design, but the layout engineer is working actively in a real co-design with the mechanical engineer. This is the key element where it's not only transferring data via IDX or some other methodology to the mechanical engineer, it's really how they work together, because an electronics design without mechanical is not complete, and vice versa. Then when you look at the way how this integrates with Teamcenter as a digital thread, on one side you have the ability to synchronize the library between the engineering environment and Teamcenter, and that includes library, approved vendor lists, 3D models. That all is going to be synchronized. And of course, you have the data that needs to be synchronized in terms of variants. I don't know who is using variants in this room, but variants are a big pain in the engineer's neck when it comes to bringing the variants together from the electronic side and the mechanical side. So there is a lot of work that needs to happen here typically, and we have automated that quite a bit. And then of course, when you look at the engineering BOM or design BOM, that is the core on the joint BOM. This is an area where we have put a lot of effort in place together with the Siemens team to make sure that you have this BOM management, CAD BOM alignment early on. So the ECAD team and the MCAD team are working together on the same BOM, based on the same BOM that is residing in Teamcenter from the beginning. And then of course you have the entire supply chain management and supply frame integration that is bringing procurement and engineering and manufacturing together to look at the same data set of components that are available in the life cycle. So that is pretty much the high-level view of the different concepts that this picture represents. I know it's a lot of detail. So when you look at the component and the design digital thread, I'm having a few topics that I would like to cover today. And the picture you see here is kind of a representation of, there is a workflow that needs to happen across the different swim lanes in your organization. You have your engineer, your component engineer, your supply chain management, the librarian, and Teamcenter working in lockstep in order to ensure a automated, out-of-the-box workflow to make sure the data is in sync. That's what we're focusing on right now. So when we look at the synchronization process between ECAD, MCAD, and PLM, it's a multi-step process. So you talk about the engineer, the component engineer creating a part on the EDM side. They are not creating this part in isolation. They may pull the part number, the component part number from Teamcenter, then create the part. Of course, once the data is done, you synchronize what needs to be synchronized from here through a push-button solution into Teamcenter. So you sync into Teamcenter right away. You can do this on a regular basis with a job, a cron job, or you can say, I want to do it right now. Then, of course, you use that data that is coming out of Expedition EDM and the common BOM that has been available in Expedition. So you look at the parts that are committed to that design, placement Expedition, and of course, then you update your NX environment. So you want to make sure that NX is using the same data, the same BOM, the same models, as it's going to be validating and replacing or placing some of the key components, such as connectors, etc. Now, the interesting is, when you look at alternate cells, if you have a component that is available horizontal or vertically,
In NX, that means you have two different models that you have to put in place. We are going to synchronize that by having, on one side, the ability in Expedition to create alternate cells. We synchronize that to Teamcenter and tell Teamcenter, look, for this horizontal installation or horizontal component, there is no alternative. It's vertical. You make your changes in Expedition, you update, and that is automatically updated in NX as well. So there is an automated process in terms of workflow, which is usually costing engineers a lot of time to get that synchronized. And then, of course, you have the final review in Teamcenter of that entire one. So when we dive a little bit into detail, time check. Dive a little bit into detail. You have here the synchronization task. So pretty much you have the ability to say, I'm going to create a new part, request a part number from Teamcenter. That's going to be automatically populated in my part creation process. And so you pretty much create that new part. When you create a new project, you say, you go to Teamcenter and say, I want a new project number. You pull that number, it automatically creates a project in Teamcenter, that automatically creates a project on the engineering side. Then that is the creation process. You kick it off that way. When you look at collaboration, there is a new object in Teamcenter. That's called co-design for board. And that co-design for board means really ECAD, MCAD co-design. It doesn't mean file exchange, it means co-design. It's an object that is residing in Teamcenter, managing the workflow, full traceability between Expedition and Teamcenter. So here is a quick demonstration that I want to run here on this. So pretty much what we are doing here in this video is we are creating the parts in Expedition, and of course those parts need to have form-fit functional alternatives. So you pretty much look into your own library. If you don't find the part in your library, you extend the search and say, I'm going into the web, looking for parts that have an alternative, a real alternative to the component that is in my system that I need. And so you look at the parts, and then you say, I want to create a new part, and that new part request then goes to my component engineer together with a link, so they don't have to re-enter the data, as I mentioned earlier. And it's going to update that data right away, import the data. The component engineer can look for what is part of the approved vendor list and the approved manufacturer list, updates the component, and then makes it available to the engineer as a released part. In addition, of course, you have the ability to look not only for comparison of those components, but then also to make sure that you create the alternatives. You synchronize that with Teamcenter, and to make sure that the components are available as alternative parts, as alternative cells or footprints, as a housing in Teamcenter. So what we do now here is pretty much synchronize with Teamcenter, update the Teamcenter environment with that data set. And then, of course, when that is happening, you have the ability to make sure that you are actively synchronizing not only the cells, footprints, but also the BOM, Teamcenter, and make sure that the data is available in both ways. All right. So when you look at the next steps in that, specifically when we talk about the collaboration between ECAD and MCAD, it's going to be that you place that part in Expedition, as I mentioned earlier, update the NX assembly, and then create that alternate cell. So horizontal, vertical. And so here's an example for how that could look like. You talk about components that are available in different orientations, and of course, for electronics, that means the same component, it just means different orientations. On the NX side, it means different cells, different housings, different 3D objects that need to be synchronized, and we are doing this with Teamcenter. And here's an example how that looks like. So this is, first we do it in Expedition. You see those two white components up here. Doing this, I hope it's running. Oh, sometimes you have to press a button. Okay, So now it's changed. I changed that part in Expedition. I see my component here in the list on the left and change it to vertical. And then I can have a look in Expedition 3D, how that looks like. You see the vertical orientation. Then I go into NX. Say, okay, I'm going to request a change to my mechanical design. That happens through the IDX exchange that you saw earlier. That's driven by PCB exchange on the NX side. So you see here on the bottom, there are two different parts representing the same functional component to different enclosures. Now in NX, what we're doing is we are opening that collaboration object and look at what is the request that came from electronics engineering. I can compare, I can look at that change, decide whether I want to accept it or not, and then you see here, then it's automatically updating that component to be vertical. And that's pretty much it. So it's an integrated process, and you see here in, I think that's in Team Center, so how the component looks like. That component is automatically synchronized with Team Center. How's that for processing? Like it? Okay. So this is pretty straightforward, and this is out of the box. So there is no customization required. This is the work that we have done over the last 8 years to bring the three different worlds, NX, Team Center, and Expedition together on the Siemens side. So if we want to switch gears, I mentioned supply chain challenges that our customers are communicating with us. Some of the supply chain challenges are not done after COVID. There is still some aftermath of what happened with COVID and with all the latest tariffs and export control requirements. We know that a lot of customers have challenges to really bring a design into manufacturing. And one typical issue is the engineer chooses a part that goes into the BOM. The sourcing engineer, sourcing specialist, is looking at this part and says, looks like that part has 10 months lead time. So you have to go back to the drawing board, make changes on the engineering side. So why don't you give your engineers the ability to look at these options in the first place? Not saying I want to pour this into concrete right away, but they want to make sure that they have the choice and the ability to decide much earlier at the point of design that this is going to have an impact. So pretty much when we look at this, it all starts again on the engineering side with Expedition EDM. That's where all data resides. And that comes together with the content program. We are going to provide, as a free capability, the supply frame integration, which is part of the Siemens portfolio. But you could also have silicon experts, Z2 data, Accurate, whatever you have in your environment. And then, of course, the PLM environment. So these three components work in lockstep in order to enable supply chain resilience more effectively in your environment. So pretty much when you look at the different pieces of this flow, it's pretty much a round trip that starts on the bottom with some part intelligence that your engineer needs in order to have a better understanding if that component is available or not. So when you look at this, so we are going a round trip here counterclockwise. The engineer is looking at parts. They're looking at the parts that are available in the library today. And those parts are the released parts, the qualified parts on the lifecycle control, synchronized with Team Center. So everything is pretty much, that's your gold data set you have in Team Center. Now the engineer doesn't find a component that he needs because the key component he needs has 10 months lead time. So what do you do about that? So you go into the web, look at, extend your search in your standard engineering environment, and extend your search into the web and look for all the alternative parts that are form, fit, function alternative. And the engineer then can look at a comparison, say, okay, compare this part, and this part, and this part. And you get a side-by-side comparison. What's the difference? They can make trade-offs, then submit a part request to the engineer. So pretty much when they are incorporating that part into the library, they pretty much have the BOM health analysis, but then they also have a risk analysis on the engineering desktop before your sourcing engineer is going to get involved. They have already a risk analysis saying, here is a life cycle risk, here is a lead time risk, here is a cost risk, based on the information that you have as parameters in your engineering environment. So this data is going to be available on the engineering desktop to make better, faster decisions before the BOM goes into sourcing, before the BOM gets committed into the release lifecycle. So you shift left those decisions and accelerate that decision-making process. That's pretty much the way how we are looking at this. And then, of course, when the component changes, it also creates an automatic notification. And to make things more interesting, if you are working with reuse blocks, if you have a box of Legos that your engineers are using, if a component in that reuse block goes end of life or is having an issue, it's going to be flagged across the entire library right away. So you can say my components X, Y, Z are getting end of life or having issues. So please don't use that reuse block anymore. That's an automatic process that you can set up. So just for sake of time, let's look into the integration. How does the integration look like? What are the key differences that we are providing in terms of the integration between Expedition and Teamcenter? So when you look at the standard environment, you have, on one side, you have your engineering environment on the left. That means you have your EDM server, which has all the different data sets, has the design data sets, and you have the engineering client. But then you have on the right side, you have, for the most part, you have EDA gateway. That is the key element of what is available to most of the CAD tools. Now, when you look at Active Workspace client, that is something that is not necessarily going to be available. But we make it one piece. Active Workspace is integrated on our side on the engineering desktop. That means the engineer can look at the data not only from his engineering classes, but also from the Teamcenter classes that he can put on in the same environment. That makes it much easier for the engineer to have a common view with Teamcenter. You have a much easier way of synchronizing your logins. You have a single sign-on between Expedition and Teamcenter. So it not only provides engineers with better data, it provides also more security in that environment. So the second point that is important is, how do I know that my design data that I have in Teamcenter are in sync with my engineering environment? And this is where we have in Teamcenter a little icon on the side that gives me a view right away. The data in Teamcenter is outdated. The data in Teamcenter is in sync with engineering. There is some information that is approved. There is information that is pending approval. So you have all these different icons so you can see right away what is the status of my design as you're going to look into Teamcenter. And of course, it's not only the data of the status, but also the metadata around what is the completion rate of my design. What is the information about the design. That is automatically synchronized with every check-in and with every release into Teamcenter. In addition, when you release your design into Teamcenter, we don't allow a release into Teamcenter if, for instance, the manufacturing data is not in sync with the design data. You have to make sure that the data is in sync. I remember once, I was working with a customer asking for a demo data set. And I got the demo data set from the ECAD side. And it took us 2 months to find the right mechanical enclosure, because they gave me a front panel that didn't fit the design. And took took them some searching for that design. So this is something where we are making sure that this is not going to happen, that the data is going to be in sync based on metadata, based on manufacturing data, based on design data. But you know what? The most important is when you look at the engineering process integrating with Teamcenter, if you can't measure it, you cannot improve it. That's why we have also extended analytics that we are providing with the Expedition EDM environment that is also being able to synchronize with Teamcenter. So to give you some examples, you can get a status of what's the number of components in what life cycle state. So you can get that on the engineering desktop, and we can sync that data into Teamcenter. So here is, for instance, more information about the designs. So there are a number of different reports. These are just examples of reports that you can generate. And so for instance, here we have design status statistics. How long did it take to complete a design or to go from one design stage to another? All this data is going to be captured on the Expedition side. We can synchronize with Teamcenter. Or, again, the life cycle, the status of my design. How many designs are in what state? Where do I have schematic and layout in sync? Where is a task missing to get the data synchronized? So I can get that as an administrator right away, and that information is crucial for project managers to understand where they stand with their design. So again, a lot of textual reports. One interesting part is definitely security audits. One challenge that we hear from customers is, I need to make sure that design data is not going to be synchronized with an area, with a region that must not have access. The other use case I've seen is that an engineer who has access to my data in Germany, if he's traveling to UK, he must not have visibility to that design based on data access restrictions. So this is an important piece that we are working on, and that we have released just half year ago, and having that increased security, and of course synchronizing that with Teamcenter. Now, the interesting part is when you look at anomaly detection, for instance. So if somebody is exceptionally often trying to access a design or trying to download a design that he should not have access to, there's a flag going on with IT, so that anomaly then can be reported, and of course it gives you the ability to react much faster to a potential red flag if somebody is trying to grab data that they're not supposed to. In addition, when we talk about security, it's not only what's in the product, it's also about how the product is being developed. So we are using the same security, cybersecurity, and quality standards that you use from Siemens Teamcenter, that you use from NX. We're having the same engineering process that ensures data integrity and consistency and security from the get-go. The last piece I just want to highlight, and I think we're running out of time, is that cat bomb alignment. And cat bomb alignment is a crucial part when we talk about the data that is going to be in Teamcenter. You see here on the left, the data that's going to be in Teamcenter, and of course, then having a drag and drop capability to bring that into your aligned BOM, and have the ability then also to view components within that discrete BOM. So that is an integrated part that is also new with, I think, Teamcenter 2406, when we brought that out, that cat bomb alignment. So pretty much, you have then also the ability to look at individual components that are on that particular BOM. Now the interesting part is, this data is not just a one-time change, it's a synchronized view. So if something changes on the electronic side, that's automatically updated on the Teamcenter side. I think that's the beauty of making sure that you have that full alignment between your ECAT, your MCAT, your capital, your software BOM, and the Teamcenter side. So that is pretty much where you have this full integration. Just looking very quickly into a couple of things beyond Teamcenter and Expedition. there are some additional capabilities, specifically when you talk about ECAT-MCAT collaboration. What you heard this morning is definitely the collaboration between ECAT and MCAT. There is a lot of IDX type based objects that are supported by many of the CAT tools of the MCAT side. The problem is that this is not representing everything that your mechanical engineer needs to know if they do advanced designs. So we extended this by having a deeper integration between Expedition and NX, very tightly knit together in order to manage all the different objects that are required in order to have a real electromechanical co-design. That goes not only into the standard objects, but it includes flex rigid, it includes traces, it includes solder mask, all the different things that are important for engineers to make better decisions. The other thing, real quick, the integration with Capital. And the integration with Capital, we have a process that has been established, starting, for instance, on the Capital side with Capital System Modeler and Capital System Architect. You create a bill of functions that you then can bring down into engineering on the electronic side, drive the implementation through Systems Designer on the electronic side, and then integrate back into Capital through Capital Devices by establishing an ICD. So there is a full round trip between Expedition and Capital. If there are changes, Capital is going to be updated through the ICD. And ultimately, when you look at the vision, having a single view of a component is critical. So we have right now already a tightly knit standard out-of-the-box integration between Expedition and NX. And the Capital solution is a little bit of a customization right now, but our vision is to bring all the different domains together. So a connector on the electronic side is the same connector used on the Capital side, the same connector used on the NX side. So that is a single point of view for every component that you create. On the verification side, there's a lot of things that we can do between Expedition and SimCenter to make sure that the designs are verified and in sync, whether it's thermal, whether it's system simulation. And on the manufacturing side, I mentioned this already before, it's the integration of a digital manufacturing model that you want to put in place between ODB, through ODB++ between ECAT and MCAT. So I hammered a lot of details. So let me conclude that really quick. So when we talk about integration, there is a tight integration between Expedition, Teamcenter, NX, and Capital. So we are working in lockstep with all these different authoring tools with a central type environment with proper management on the Teamcenter side. So different use cases are addressed across this flow, whether it's the tight ECAT-MCAT co-design, whether it's the integration with Capital for making sure that you have a proper system of systems integration. And then, of course, when you look at the summary, I mentioned to you already that we have 5 different threads, and there are 5 different summaries. The first is, of course, to make sure you have a proper library integration. The proper library integration means that synchronization, continuous synchronization between ECAT and Teamcenter. The second is to make sure that you have a proper release and change management. Out of the box, of course you can get a lot of stuff done with consulting, but how do you make sure that the data, the integration is sustainable and efficient? So we have this out of the box functionality. And of course, when you look at the workflow, that is when you talk about out of the box, and the traceability, that can be done with Expedition and Teamcenter. The center is, of course, the authoritative point of truth with Teamcenter. All the data needs to be managed on that side. And of course, you have, as a result, a cross-domain collaboration and integration between Expedition, the authoring tools associated with it, and the Teamcenter environment. So pretty much, I believe it gives us 3 major values. If we put this all together as a single environment, On one side, we can help you reducing all the manual processes, the Excel spreadsheets, the Word documents, the informal processes, by having an out-of-the-box capability. And with an out-of-the-box capability, we have on one side more time for engineers to focus on innovation, not on making sure that data isn't served. And for the solution architects and the IT side, it means since we have a integrated environment out of the box, significant lower cost of ownership. And I think that is the message I want you to take away from this session. We have a tight integration, which is out of the box and can help you to make this thing more effective. Thank you.